stoichiometry using concentration here, molarity. So in equals reaction, we can use the volume and the concentration of a reactant or product to calculate its amount in moles. We can then use the stoichiometric coefficients in the chemical reaction, chemical equation to convert to the amount of another reactant or product in moles. Remember that in stoichiometry, we always need to work with moles. So we don't, if you have a mass, we're going to convert to moles. If you have a volume, you need to convert to moles. So if I have moles of A, I can find moles of B. Doesn't matter if this B is a product or reactant. So we're going to use this and the ratio, chemical equation ratio. Okay? So what is the chemical equation ratio? Is the stoichiometric coefficients. Imagine if I have a 2A plus B given C. So that's 2 and 1 over here and 1 over here. When you don't see number 1 is number 1. So I have 2 moles of A that requires 1 mole of B to produce 1 mole of C. So here, if you have the volume, you can use the concentration or the molarity over here that you know that is moles per liter to find the amount of A. And if you use the chemical reaction or the chemical equation ratio, which is the coefficient, stoichiometric coefficients, you can find the amount of B. And again, if you use the concentration of B or the molarity of B, you're going to find the volume. So first, let's see how that works over here. So here in this problem is asking a very easy question, asking what is the limit reactant if you mix equal volumes? See that we have equal volumes of 1 molarity solution of A, so 1 molar solution of A, so moles per liter. When you see caps letter here, this is molarity, is moles per liter, and 1 moles per liter solution of B. So I know that I need to work in moles. So if I have a liter, so if they say that are equal volumes, I can choose 1 liter for both, right? And I know that I have 1 mole of A, so we're gonna use A over here per liter of A. So we're gonna cut liters and liters over here, and they're gonna have 1 mole of A. And the same thing with B. So I know the concentration is the same, so moles of B per liter of B, so we can cut off over here, and we have moles of B. So if you look at the stoichiometric coefficients over here, I know that 1 mole of B will require 2 moles of A, and I only have 1 mole of A. So this is my limit reactant here. Okay? So let's see how that will work, how this works, and real chemistry problem, numbers and reagents, everything. So let's see this problem here asking what volumes of 0.200 moles per liter sodium hydroxide will react completely with 25 milliliters of 0.500 moles per liter hydrochloric acid. So first thing here, you need to be able to write down the reaction and check if this chemical equation is well balanced. So let's start with this. So we have a sodium hydroxide reacting with hydrochloric acid. This is as the base reaction. This is a neutralization reaction. So we have over here hydrochloric acid, and when you look to the elements that we have, the atoms, see, I have how many hydrogen in this side? So I have 2 hydrogens, and I have 1 chlorine over here, and 1 sodium over here, and I have 1 oxygen, right? So when you go to the other side, so I can just change the color of my pen over here, so then we can understand better. So when you go to the reactant over here in this side, I have 2 hydrogen as well. So see, I have 2, and I have one chlorine over here, so 1, and I have 1 sodium, and I have 1 oxygen. So they match. So I have the same number of atoms in both sides. That's perfect, and it's well balanced. So now I know the molarity is moles per liter, right? So and here I have the volume of milliliters. So we're going to convert this first, and we'll be dividing, because I know that 1 liter is 1000 milliliters. So we're going to cancel out this unit milliliters, and I have 0.025 liters of hydrochloric acid. Now with the volume and the concentration over here, I can find moles. So let's find moles. So I have here 0.500 moles per liter. So this is the molarity of hydrochloric acid. See how important it is to work with the units? I know that up here is the unit that I want. So I'm looking for, so I can cancel out liters. I will multiply 0.025 times 0.5, and I have here the moles of hydrochloric acid, 0.0125 moles. So now, through the coefficient, the chemical equation ratio, I can find the moles of sodium hydroxide, right? So I have the moles of hydrochloric acid, and this is the mole, the ratio, the equation ratio over here. So the coefficients, stoichiometric coefficients over here is 1, 1, 1, and 1. I know that 1 mole of hydrochloric acid requires 1 mole of sodium hydroxide. So it's 1 per 1. So actually I need the same quantity of sodium hydroxide to react with the hydrochloric acid. So now with the concentration, with the molarity of sodium hydroxide, I can find the volume of sodium hydroxide over here. So this is the volume, and here, so I have the equation ratio, this is the molarity, and this is the moles that we found over here. Pretty easy, same thing that we did before with the mass of some reactants, that we use the molar mass to find moles first. Now you have volume and concentration, so you're going to use concentration to find moles before you find the moles of the other reactant or product in your reaction. That's it. That's all.